Okay, let's talk about where we are. We're in the second part of section 3.3. And we've learned these derivative rules. Derivative of a constant is always 0. Derivative of a power rule, x to the n, is nx to the n minus 1. Derivative of a product of u and v being in factors is derivative of the first term times the second plus the first term times the derivative of the second. The derivative of the quotient rule for derivatives is u over v. It's a derivative of the top times the bottom minus derivative of the bottom times the top over the bottom squared. And the derivative of e to the x is e to the x. So we have a Mod Podge to finish up our section. And this one is a product rule, where we have a power rule times e to the x. All right, so this means that we're going to have y prime is equal to, and I'll do the first term, 12x to the 11th power e to the x, because I took the derivative of the first term. Plus, I'm going to have x to the 12, and I'm going to take derivative of the second term, e to the x. And I'm done. That was simple enough, other than the fact that we have a plus in between, and we take the derivative of e to the x is e to the x. All right. Now this one's interesting for two reasons. We have a fractional exponent, meaning we have a square root, a fourth root, and a function of e to the u. So that means we're going to have du e to the u. So that we're going to take the derivative of the u, and then take the rest. So, and it's an addition, so that makes it even easier. So we're going to have y prime then is equal to 5/4 x. And now remember how the fractions work. I have 5/4, which is an improper fraction. I'm going to subtract 1. Well, in order to do that, I need a common denominator, so that's going to be 4. 5/4 minus 4/4, 1/4. You can use your calculator if need, for those of you that have had extensive use of it. So we have the derivative of negative 3x is negative 3 e to the negative 3x. And I'm going to clean it up. Y prime is 5/4 x to the 1/4 power minus 3e to the negative 3x. All right. Now we come to this one. This one's flat out nasty. If we did the product rule, you would get lost. But I noticed something. I mean, I could do it, but I'd have to be very careful, and I'd probably have to tape this about 5 times. So, what do we notice? It's a factored perfect cube. Of a cubed, and it's a plus, b cubed. If I had these two, it would be the base values, open parentheses, the square of the first, opposite sign, their inner product, plus square of the last. So we notice that that's exactly what we have. Or we could use FOIL. If I did FOIL, because if you're from Missouri, and that's okay, and I multiply by x plus 2, I would first do the x, right? X cubed minus 2x squared plus 4x. And now I'm going to multiply by the positive 2. I will get a 2x squared, a minus 4x, and a plus 8. I would notice that I have additive inverses there, and I have x cubed plus 8. All right, whichever method you like is what you should use. And that will help you in doing the math. Okay, that would be an easier way of doing the quotient rule. So we have y equals, and I'm going to put x cubed plus 8 over x cubed. All right. So we're going to have y prime is equal to the derivative of the first term, which is 3x squared, times the bottom, minus the top times derivative of the bottom, all over the bottom squared. All right, so let's do some math. I have hay fever, and I'm so sorry. So I'm going to multiply the negative 3x squared through all of it. Oh, that's a minus. Sorry about that. Oops. Can't do math, can I? All right. And the bottom is x to the 6. So these are additive inverses. So I have a negative 24 x squared over x to the 6. 24. Yes. All right. As we do that, I'm going to reduce it and get negative 24 over x to the 4th. And there you have it. How is that? Is everybody comfortable with that? Okay, any questions on that? Is everybody good? All right. So if we're good, then we can have we're done on that one. So let's see what else we can get into. We have a problem, and here we go. It says find the equation of the line perpendicular to the tangent of this. All right, so let's look at the word perpendicular. Slope, okay? What perpendicular is the opposite sign reciprocal of the slope. And it was written that if we wanted the perpendicular slope, we would do opposite sine 1 over the slope that was given. So that the perpendicular would be the opposite sign reciprocal. All right. And we have a point of 3, 1. And we have to find first, find slope at the value of x equals 3. So we have y equals x squared minus x cubed minus the 9x plus the 1. 3x squared minus 9. Now we're putting in the 3 into there. And we're going to say change of y over the change of x because we want to make it the slope. 3 times 3 squared minus 9. So this is 927 minus 9. We get 18. Now we want the perpendicular slope. So we're going to have the opposite sign reciprocal of what we have. So this is our perpendicular slope. And they want the tangent line. So now we're going to construct the tangent, the perpendicular tangent. Tangent line. Good job. All right. So we know our point is 3, 1, and our perpendicular slope is a negative 1/18. All right. So let's do it. And we have everything we need. Two negatives make a positive, and this would be 3/18, or a positive 1/6. All right, so we have the perpendicular. Now we want to answer the B part. And the B part says the smallest slope of the curve. Okay, so we consider first our change of y over change of x function, our derivative function. And our derivative function said that I had the 3x squared minus 9. So what we're looking at is this guy right here. What value of x? That's a question. What value of x will get, or give us, I should say, not yet, give us the smallest slope. All right, so what we want for the smallest slope is to drop in any x we want. But what do we notice? We notice that it's squared. Because it is squared, x, it's a squared x, no negative, or positive will give us a value less than negative 9. In other words, if we put in a 2, then I have a positive 12. If I put in a 1, okay, that's the small, it'll give me a negative 6. So therefore, x must equal 0, and the smallest slope of the line is negative 9. Negative 9. Okay, now let's see. At what point on the curve does the curve have this slope? On what point on the curve? All right. So now I'm going to have to turn on my calculator, and I did not starting this lesson, and I'm sorry. But I shall get that up there. Let's see, I want to close that. Hold on. Here we go. All right. So we want to go to our y equals and clear out anything I have there, which is quite a bit, isn't it? And I'll put in the original function, x cubed minus 9 plus 1. All right. Oops, forgot about that. Let me clear it. X cubed, and I have to go sideways. I always forget, sorry. 9x plus 1. This is my original function. And I want it at 0, so I'm going to go zoom 9 and zoom 6 rather, and I've got it there. I go second calc value at 0. All right, so at 0 I have 1. All right, so the point, the tangent point, oops, at which slope is negative 9 is the point 0 for x and 1 for y. All right. Is everybody comfortable with that? Okay. Well, now that I have my my item up, and I know that I can have the tangent put in, the perpendicular, I'm sorry, perpendicular. So the perpendicular was negative x divided by the 18 plus 7 over 6. And I'll graph it. And you can see that at 3, 1, we have a tangent perpendicular at that point. And you can see it there. Of course, this isn't drawn to scale, but I guarantee that's what it is. All right, so let me pull that back up. Let's see what the C says. Find the equation of the tangent to the curve at the points where the slope of the curve is 18. Now, here on the C, we want all tangent lines where the slope is 18. All right, now we did have the first one, the point 3, 1. We have the slope at 18, but we have to think about it. We had y prime equals to 3x squared minus the 9, which is how we got the 18 to begin with, but it's a square. And so what we want here is we understand that 18 has to equal 3x minus 9. So I'm going to have the 27 equal to the 3x and it squared, sorry about that. And then I'm going to divide, so I'm going to have 9 equals x squared. When I do this, I'm going to get plus or minus 3. Now, the ordered pair we have was for the plus one, so we need the negative one. All right, so let's do that. And here I'm going to do second calc value at the negative 3. And I get the value 1. of course, because it's symmetric in that regard. So we have a 1. These are the two lines, and they want all tangent lines at 18. So let's do that. Now remember, tangent lines will only touch. Perpendiculars go through. So that's what you know. All right, so we have y equals m parenthesis x minus at x of 1 plus y sub 1. Here we go. Y equals 18x minus the 3 plus 1. Y equals 18x minus, what is that, 2454 plus 1. Y equals 18x minus 53. This is for the point 3 and 1. Now I'm going to do it for the point negative 3 and 1. Y equals 18 parenthesis x minus the negative 3 plus the 1. Y equals 18x plus 3 plus 1. Y equals 18x plus that 54 plus 1. And that one, my guys, is y equals 18x plus that 55. So let's go up here and let's work that. Hold that thought. Sorry. It's right on where I'm working with it, so it's kind of hard to move it. Well, that's not going to help you any or me. Just a second. There we go. I'll move that up. Move this across. There I go. So I'm going to go to the y equals. I'm going to take the perpendicular out, and I'm going to enter 18x plus 55 and 18x minus 53. All right, and remember I have that already on my graph, and we have this one here at 18 and this one here at 18. So if I do second calc value for my negative 3, I get negative 1 for the blue, and I get a negative 1, a 1 for the red tangent line at slope 18. Well, then I'm going to do second calc value of a positive 3 and enter, and it's on the black and blue line. If I do second calc value for a 3, I'll get the 1, and then if I do down arrow for the red and then down arrow again for the black, I'll get the 1. So you can see that those are two tangent lines with a slope of 18. Now we're at the last one. Find all points x, y on the graph of 2x squared minus 3 with tangent lines parallel to the line y equals 9x plus 1. Our first concept is, what is the slope? Well, the slope is 9 because y equals mx plus b. And parallel lines mean that we have two lines going in the same direction but never touch equidistance from each other. All right. So now we know the slope we need. And now we have our function. So we're going to take the derivative. So that's going to be f prime of x is equal to 4x minus 3. and we want the slope, which is this entire thing, it's our slope. We will then calculate the slope for it equal to 9. We want to find the value of x. To cause derivative to be 9. All right, so we're going to have 9 equals 4x minus 3. I'm going to add 3, so I'm going to get 12 equals 4x. I'm going to divide by 4, then x equals 3. Okay, now we have that in this parabola at 3. So now we're going to find, now the parabola is this way, so it's only going to have 1, and it is in the positive, yes. So we're only going to have 1 that works. So we want to find the ordered pair. All right, so we want f of 3. Okay, to find the value of the original function, I'm going to have f of 3 is equal to 2 times 3 squared minus 3 times 3. And this is 9. 18 minus 9 is 9. So the ordered pair that we need is x is 3 to get the slope of 9 and the value of 9. So I thought that was pretty cute, right? So now we're going to construct the tangent line. And we have a slope of 9, and the point is 3 and 9. And we'll have the answer as 9 parentheses x minus 3 plus the 9. We sure have that 18 showing up everywhere, don't we? 18 on the slope for the tangent at 3, 1, and here we have the previous problem, and now we have 18 as a minus on a problem that is a quadratic. So we want to check that because we always want to check it. So here we go. It's our last problem, and I want to make sure everybody's on the same page, that they have options here. I'm going to go to the y equals. I'm going to clear all of the other ones. And I'm going to enter my original function for the 2x squared minus 3x. And I'm going to put our tangent at 9x minus 18. And I'm going to put my parallel line, which was 9x plus 1. All right, now remember, this one's parallel to that one because the 9s are the same, and we're looking at that. All right, so I have it on a 10 by 10. There it is. You can see that the third one is parallel, and we want that, we want the second calc value and the at 3, and we get 9 for the original function. And now I'm going to go down, and I'm going to get for the, the black one. I got the black one. I didn't get the red one. There's a red one. 3 and 9 for it. Okay? Is everybody comfortable with that? All right. So we learned a lot on this lesson. And to finish it, this right here is all the ways of reading the symbols. This is read y prime, y double prime, d squared y over dx squared. And so this one is triple, wide triple prime. This one's super N, and this one, I think you see those in engineering. I've never seen them in this fashion, but I think you see them in engineering. I want to thank you for listening. Now you can do the homework.